Welcome back to my channel and welcome to my SSCE mathematics series from zero to guru. In this video, I'm going to continue from where I stopped on laws of indices. In the previous video, I gave 4 out of the rules. And I explained that these rules are very simple and it could be used to generalize or to solve some of your expression involving indices. So the first rule, if you did not forget, is that when you have the same base, and you are to multiply them together, so it means you don't have to stress yourself. Just take one of the index, one of the base, since they are the same initially, then you do what? So you had the index. You had the index together. So that is a raised power m multiplied by a raised power n gives a raised power m plus n. So the second one follows. So but instead of multiplication, you have division. You don't need to stress yourself. That's going to give you what? A raised power m minus n. So that is when you have the same base and you have to divide them, you don't need to stress yourself. Just take the base and subtract the index. So the third one is the what? The zero index, that is any number raised by 0 with an exception of 0 is going to give you 1. And the last one which I covered was that of a negative index. So that is the negative index gives a reciprocal of the quantity. So for example, if I have a raised power minus n, then the same thing as 1 divided by a raised power n. In this video, I'm going to continue from where we stop. So the next rule I'm going to consider is what? Is the power rule. Is the power rule. So what does that entails? Let me give you an example. See, suppose I have something of this nature. A raised power 2, everything raised power 2. You know the same thing as a raised power 2 times a raised power 2. That is a raised power 2 multiplied by itself. How many times? 2 times. And by your multiplication rule, when you have the same index like this, what are you going to do? You add the index. So when you have the same base, you have the index. So then that's going to give you a raised to power 4. That's going to give you 8 to power 4. Okay, now another example, let's say I have a raised power 3, everything raised power 3. You know, according to what I have by index a raised power 3, that is, you are to multiply what you have inside this bracket by itself. How many times? 3 times. That's a raised power 3 multiplied by a raised power 3 multiplied by a raised power 3. If you apply your multiplication rule, what are you going to do? So you are going, since we are multiplying now, so it means you are going to add the index together. That's 3 plus 3 plus 3. So that's a raised power 9. What do you observe? You have observed that here when I have a raised power 2 everything square, at the end of the day, I have a raised power 4. You understand now? Likewise, when I have a raised power 3, everything raised power 3. So I have a raised power 9 as my result. So in general, you don't need to stress yourself. So you will see that it is as if you are multiplying these two guys together. 2 times 2 here, which is something as a raised power 4. Likewise, 3 times 3, which is a raised power 9. In general, when you have a raised power m, everything raised power n, then you don't need to stress yourself. That's going to be what? A raised power m times n, which is a raised power m n, which is a raised power m n. Let me give you an example to back it up. Let's say I have 3g, everything squared, then everything raised by minus 2. So everything raised by minus 2. You know, according to that rule, that's going to be what? If we are to simplify this, that's going to be 3g raised by 2 times minus 2. Don't forget. So the power rule. Don't forget your power rule. So if that is the case, then you can continue. So then this is going to give me 3g raised by minus 4. Don't forget your bracket, because if you don't put the bracket, then you are saying it is that g alone who owns -4, and that is wrong. They owns it together. And don't forget your negative index rule. That is when you have something raised by a negative number, so it's going to give you the reciprocal of that quantity. That's 1 divided by 3g, everything raised by 4. Then if you do it one by one, if you still apply the rule, that's going to give you 3 raised by, this is 1 times 4 multiplied by g raised by 1 times 4, which is 4. That's going to give you 1/81 g raised by 4. So 1/81 g raised by 4. It's as simple as that. So let me go to another rule. So that's fractional indices. Fractional indices. So we've been doing something in terms of positive and negative. What if you have a fractional indices? For example, if I have 36 raised power half multiplied by 36 raised power half. That is not difficult to do. You can apply your multiplication rule. Don't forget we have 36 as the base and they are equal. You just add the index. That will give you 36 raised power half plus half. That's 36 raised power half plus half, which is 1. That is 36. You understand? Also, don't forget if I have square root of 36 multiplied by square root of 36. According to your, laws of roots, square root of 36 multiplied by square root of 36 will give me square root of 36 everything squared. You understand now? So, or if you don't want to stress yourself, we can just say here that square root of 36 is what? Okay, don't let us stress ourselves. Square root of 36 is 6, right? Then multiply by square root of 36 is 6. 6 times 6, that's 36. What do you observe? You observe that this guy equals to each other. You understand now? So that's what the law is saying. That is, you don't need to stress yourself when you have your fraction as half. So that is, for example, when you have 36 raised power half, then you don't need to stress yourself. The same thing as square root of 36. For example, a raised power half is the same thing as what? Square root of a. Likewise, let us do it for cube root. When you have your fraction in terms of 1/3, let's see what is going to happen. So, for example, let's say I have 8 raised by 1/3 times 8 raised by 1/3 times 8 raised by 1/3. So, that is going to give me what? So, if you apply the multiplication rule, that's 8/1/3 plus 1/3 plus 1/3. That's 8 raised by 1. So note that, which is 8. Likewise, let's say I have cube root of 8 times cube root of 8. Sorry, the 3 should be here. Multiply by cube root of 8. What does cube root of 8 mean? That is, what number are you going to multiply by itself 3 times to give you 8? That is 2. 2 times 2 times 2, that is 8. So you have 2 times 2 times 2. That gives you 8. Can you see that? So if that gives you 8, then we can conclude adequately that 8 raised by 1/3 is the same thing as cube root of 8. You understand now? Meaning that when you have x raised by 1/3, it's also the same thing as cube root of x. So if you join that together, remember the first one I did, which is x raised by 5. I said x raised by 5 give what? So gives x raised by half gives what? Square root of x. Likewise, x raised by 1/3 gives cube root of x. So in general, you don't need to stress yourself. When you have a raised by 1/n, then you are going to have nth root of what? Nth root of a. And don't forget, what does that mean? That is, what is the number you are going to multiply by itself nth time to give you what you have inside this radical. So inside this radical. Okay, now let's say what you have are the index. So if the fraction is not 1, what I'm trying to say is that, for example, if I have 1/n now, if the numerator here it is not 1, what are you going to do? Let's say I have something like a raised by m divided by n. That is not difficult to do as well. So you can say a raised power n multiplied by, or let me say a raised power 1 over n times m. Anyhow, because multiplication is commutative. If that is the case, I can do it as a raised power 1 over n, everything raised power m. You understand now? And according to this law, when you have a raised power n, then it is the same thing as what? Nth root of a, everything raised power n. So that is that. That means you don't need to stress yourself. When you have s raised power a over b, then just consider the denominator. The denominator will be your nth root, that is bth root of x, everything raised power a. B root of x, everything raised power a. Do you understand now? Likewise, when you have a raised power 2 divided by 3, you don't need to stress yourself. That will give me cube root of a, everything raised power 2. Okay, now can you do this? 8 raised power 2 over 3, that will give me what? Cube root of 8, everything square. And don't forget, cube root of 8 is what? That is 2 raised power 2, which is equal to 4. So which is equal to 4. So another rule I'm going to cover, let's say you now have, the fractional to be negative. If the fraction is negative, maybe I have a divided by b, everything raised by minus m over n. That is not difficult to do. If you use your negative index, the negative index will give the reciprocal of the quantity. That's 1 divided by a over b, everything raised by m over n. You understand now? So if that is the case, you can give it to them one by one. That will give you a divided by m minus over n divided by b divided by m over n. You understand now? The same thing as 1 divided by a raised power m divided by n divided by b over m divided by n. And don't forget, if you change this to multiplication, it means you are going to interact this. So this is going to give me b raised by m over n divided by a raised by m over n, which is equal to b over m over n, a over m over n. So that will give me b over a, everything raised by m over n. What do you observe? So we call this a kind of Takiti law. I used to tell my students this is Takiti law. That is, when you have something like this, when you have negative fractional index, then you don't need to stress yourself. Just remove the index and interact what you have as the fraction. You understand now? So when I have a divided by b raised by minus m over n, then I don't need to stress myself. That's going to give me what? B over a, m divided by n. Let me give you an example to back it up. Let's say I have 32 divided by 50, everything raised by minus 1.5. That is not difficult to do. Then remember, by this negative fractional index, you can say this is 32 divided by 50, everything raised by minus 15 over 10 when you convert it to fraction, to a fraction. So you will observe that 2 can go here, 2 here, that is what? 18. So 2 here, 25. Sorry, 2 here is 16, not 18. 16 divided by 25. Then I have 16 divided by 25. So likewise, 5 can go here, 5 here, 3, 5 here, 2, minus. And don't forget the immediate rule I've just explained. If you have negative fractional index now, then you can just interact this guy together and you remove the index. You understand? And don't forget the fractional rule. This is the same thing as square root of 25 divided by 16, everything raised by 3. That's square root of 25, that is 5 divided by 4 raised by 3, which is 125 over 64. It is as simple as that. If you understand that, so let me summarize all the rule. So the first one is, which is multiplication rule. When you have a raised by m, everything raised by n is the same thing as a raised by m plus n. Likewise, when you have a raised by m divided by a raised by n, don't stress yourself. So just take a and you subtract the index. So then your zero index, a raised by 0 is 1. When you have negative index, that is a raised by minus 1, that's 1 over a. Don't forget here, your a is not equal to 0. And in general, a raised by minus n will give me 1 over a raised by n. So likewise, when you have your fractional index, so that is 1 over, excuse me, so that is a divided by m over n. So that is what, sorry, before that, that is 1 over n, the same thing as nth root of a. Likewise, when you have a raised by m over n, that's nth root of a, everything raised by m. And the last one, when you have a raised by minus, or let me say a over b raised by minus over n, that's what, b divided by a, everything raised by m over n. If you understand this, please don't forget to like, subscribe to my channel if you've not done so before, and inform your colleagues to do so. So in the next video, I'm going to continue from here. Thank you.